All right, let's get started on today's notes. So today's notes are about solving logarithmic and exponential equations. So let's just do a brief go through of all the different types of problems that we have here. So if you look at all the problems in example 1 versus the problems in example 2 versus the problems in example 3 versus there is no example 4. Interesting. The problems in example 5, example 6, so on and so forth. So what you should notice as far as example 1, 2, and 3 goes is that in example 1, there's one log on one side of the equation. In example 2, there's a log on each side. And in example 3, there's 2 logs on one side or 2 logs on both sides. So let's go through each. So the first thing you should do is you should look at the problem and say, how many logs are there? This one has 1. So when there's one log, what you're going to do is you're going to isolate the logarithm. Then you're going to rewrite an exponential form so you can solve. So a lot of times when people see this problem, they'll be like, I don't know what to do. Whenever you're working with a log and you're stuck, you need to rewrite an exponential form. Also, one thing I forgot to mention, whenever you're solving a logarithmic equation, you must always check the solutions. So the way you can check, the easiest way is you need to make sure that when you plug x back in the base, so this number, and the argument, so this number, are positive. So this one, the base is already positive, so it's fine. But if I would have gotten an answer of, let's say, -5 here for x, and I plug it back in and this becomes -3, that is not going to be a solution to that equation. Okay, so let's get started with this one. So one logarithm, so I'm going to isolate my log. Remember, I know a log is isolated if it's just the log and then the argument. So this one is isolated. And now I'm going to rewrite an exponential form. So I need my base, which is 2. I need my exponent. Remember, logs are equal to exponents, which is so to the 6th power equals my argument, 2x minus 4. So now if you see this equation is much easier to solve. So first off, we have 2 to the 6th power. You can use your hands, 2 times 2 times 6 times. Or you can break it into 2 cubed times 2 cubed, which is 8 times 8, which is 64. Equals 2x minus 4. Add 4. Divide by 2. X equals 34. Now, before you box your answer, you want to take that 34 and plug it in right here. 2 times 34 is 68. Minus 4 is 64. I got a positive argument, so I'm good. Also, the base was already positive, so I don't have to worry about that. So 34 is my answer. All right, let's move on to example B here. So I have one log. I want to rewrite an exponential form. I want to rewrite an exponential form. But before I can do that, I want my log to be isolated. Remember, a log is isolated if it's just the log and its base and the argument. So that means I have to get rid of this +1 and this times 3. So we are going to get rid of the +1 first. Just like if we had 3x plus 1 equals 7, we'd get rid of the +1 first. All right, so we're going to subtract 1 from both sides. So now we have 3 times log base 5 of x plus 2 is equal to 6. Divide both sides by 3. Log base 5 of x plus 2 is equal to 2. And now it's just like the last problem. The log is isolated. I can rewrite an exponential form. 5 to the 2nd power equals x plus 2. 25 is equal to x plus 2. Subtract 2, x equals 23. Once again, I want to go ahead and back to the original. Plug in 23 for x. 23 plus 2 is 25. That's a positive argument, so it's just fine. All right, last one. Let's go ahead and see what we're dealing with here. So I have one log on one side, the log and its base and the argument are isolated, so I can rewrite in exponential form. My base, which is x, to the second power equals my argument, which is 9. All right, so now I need to solve this. I'm going to square root to solve. Don't forget, when you square it to solve, you have to account for the positive and negative answer. So I get x equals plus or minus 3. Now I need to check my solution. So let's check 3 first. If I plug in 3, the base is positive, it's good to go. If I plug in negative 3, the base is negative, which is not good. So the negative does not work as an answer. My only answer is x equals positive 3. All right, so that's it for one log on one side of the equation. So now we are at the situation where we have a log on each side. So in these types of situations, what you're looking at is a log on each side, and if you notice, they have the same base. They have the same base. They have the same base. So what you want to do is you want to make sure that you have the same log on each side, in which when you have one on each side, that's going to be the case. So in order for this log to be equal to this log, their arguments have to be equal to each other. So these ones are super easy. They're probably the easiest ones. X plus 3 equals 2x plus 1, and then solve that. So subtract x, you get x, subtract 1, you get 2, x equals 2. Once again, you want to check your answer. If I plug in 2 here, 2 plus 3 is 5. That's positive, so that's good. 2 times 2 plus 1 is 5. That's positive, that's good. So x equals 2. Next one right here, they're both natural logs, so the arguments must be equal to each other. So I'm going to do x plus 2 is equal to 3x plus 10. Subtract x from both sides, that's 2x. Subtract 10 from both sides, that's negative 8. Divide by 2, you get x equals negative 4. Before I box my answer, I'm going to check. Plug in negative 4 right here. Negative 4 plus 2 is negative 2. Not allowed. So it's not the fact that negative 4 there's something wrong with the negative in the 4. It's when we plug in negative 4 and we get negative 2 as an argument. That's what's not allowed. Notice you will also get negative 2 over here. Even though they are equal, it's just that the natural log of negative 2 does not exist. So this one has no solution. All right, next one. I would like to set the arguments equal to each other right now, but I do notice that I have this 2 hanging out in front. So now remember your properties of logarithms. I can take that 2 and write it as an exponent. So now I have log base 6 of x squared is equal to log base 6 of 16. Now I can set my arguments equal to each other. X squared equals 16. Square root to solve. Don't forget to do plus or minus. X equals plus or minus 4. Now I want to check my answers in the original. If I were to check my answers here, I'd say, yeah, both are good. But if I go back to the original and I check the positive 4 and I plug it in for x, the argument's positive. But if I check the negative 4, the argument's now negative, which is not allowed. So I get x equals 4. Okay, so far we've seen one log on one side, one log on each side. Now we're going to see 2 logs on one side. So our goal is to get it to be 1 log on one side so that we can rewrite in exponential form. So right now it's 2 logs. So what I need to do is I need to condense this. We learned how to condense in 3.3 day 1. We also practice it in 3.3 day 2. So remember, when you have 2 logs that are being added, you can make that 1 log where you are multiplying your arguments. So I'm going to multiply my arguments. I have x times x minus 3. I'm just using brackets so that it's not super parenthesis heavy. You can also immediately distribute if you want. If you want to say x squared minus 3x right away, that's fine. So now I have common log of, and I'll write that down. I'll distribute. X squared minus 3x equals 1. All right, so the mistake that people make right now is they think the next step is to get out your eraser and erase the word log. That's not how this works. Remember, if you're working with a log and you're uncomfortable with it, rewrite it in exponential form. So here, my base is 10. So I'm going to rewrite this in exponential form. 10 to the first power equals x squared minus 3x. 10 equals x squared minus 3x. So now realize this is a quadratic with an x squared and an x. In order to solve a quadratic with an x squared and an x, it has to be equal to 0. So subtract 10 from both sides. And now you can factor. I'm looking for two numbers that multiply to give me negative 10 and add to give me negative 3. Those two numbers are negative 5 and positive 2. Remember to divide by the leading coefficient of 1, so you get your two factors are x minus 5 and x plus 2, and therefore you get two solutions. You have x equals 5 and x equals negative 2. But once again, since I'm solving a logarithmic equation, I have to check to see if either of these are extraneous solutions. So let's start with the 5. Go back to the original. Plugging in a 5 here, I get 5. Plugging in a 5 here, I get 2. That's good. 5 is an answer. Now let's check negative 2. Plug in a negative 2 here, I get an argument of negative 2. Not okay. So I'm going to cross that one off. My only solution is x equals 5. Go ahead and pause the video and try B on your own, and then just come back and check answers with me. Make sure you're checking for extraneous solutions. All right, I have 2 logs on one side. I need to condense it and make it 1 log. Since it's addition, I'm going to end up multiplying my argument. So I'm going to do this in one step. I'm going to say log base 2 of, and then I'm going to multiply these two. So that becomes x squared plus 2x, and then equals 3. All right, so now I have 1 log, and remember, I'm stuck. I don't know what to do. I'm working with logs. Rewrite in exponential form. My base is 2, so I'll start with that. My exponent is 3. It's what your log is equal to. Equals x squared plus 2x. Notice if you would have accidentally wrote 3 squared, you would have gotten 9. And when you subtract 9 from both sides, you're going to end up with something that's not factorable. So if you find yourself in that situation, you've obviously made a mistake, at least on the problems that we've made up for you. Subtract 8 from both sides. X squared plus 2x minus 8 is equal to 0, and factor. Two numbers that multiply to give you negative 8 and add to give you positive 2 are 4 and negative 2. So I have 0 equals x plus 4 times x minus 2, and once again, two solutions. X equals negative 4, x equals 2. Check to see if either are extraneous by plugging back into the original. Let's start with the negative 4. If I plug in negative 4 here, my argument's negative 4, which is not allowed. I don't even have to check in any other one. If I plug in 2 here, I get an argument of 2, which is good. If I plug in 2 here, I get an argument of 4, which is good. So my only solution is 2. All right, last but not least, still have 2 logs on one side. I want to make it 1. Whenever you have 2 logs on one side, you always want to try to make it 1. So, same base. This time it's subtraction. So I'm going to condense it still. But remember, with subtraction, that turns into division. My numerator is now a 2 from this 2. My denominator is now an x from that x. Equals. Same thing I can do on this side. I'm going to condense it and make it 1 log. Since it's subtraction, I'm going to divide my arguments. 4 over x plus 1. Now, it's just like the problems in example 2. You already have a log on each side. In order for those logs to be equal to each other, their arguments have to be equal to each other. So I can set the arguments equal to each other to solve for x. 2 over x equals 4 over x plus 1. This is a proportion. The easiest way to solve a proportion is to cross multiply. 4 times x is 4x. 2 times x plus 1. 4x equals 2x plus 2. Subtract 2x from both sides. X equals 1. Before I box my answer, I'm going to go back and check 1 on each, for each x. Plug in 1 here, I get an argument of 1. That's good. Plug in 1 here, I get an argument of 2. That's also good. So I have my one solution of x equals 1. Okay, so that's it for logarithms. Once again, just to recap, we can have a log on one side, one on each side, or two on one side that we want to make one side. If it's one log on one side, you want to rewrite an exponential form. If it's a log on each side, set the arguments equal to each other. And if it's two logs on one side, you want to condense to make it one log. And then if it's just on that side, rewrite an exponential form to solve. If you have to do it on both sides, then you're going to end up with a log on each side, and you can set the arguments equal to each other. All right, let's move on to exponential functions. So two different situations can arise when you're working with an exponential function. In tonight's homework, you're only going to see the problems like example 5. We're not going to see any example 6 in tonight's homework. We'll see more of those tomorrow. But we're still going to get a little sneak peek at them. So let's see how to solve exponential functions. So first thing you're going to do is you're going to look at the bases. Our goal is to get the same base. You have to ask yourself, can I get 2 and 16 to have the same base? And what I mean by that, can I get them both to have a base of 2? If it was 8 and 4, can I both get them to have a base of 4 or something even smaller, a base of 2? If it was a 9 and 27, like the next one's 3 and 27, so it's close, but if it's a 9 and 27, I can't get them both to be a base of 9, but can I get them both to be a base of 3? You have to ask yourself those questions. So 2 and 16, I can get them to have the same base. 2 is 2 to the first power, and 16 I can rewrite as 2 to the fourth power. So now I'm going to rewrite this. I have 2 to the x plus 1 power, and then my 16 I'm going to rewrite as 2 to the fourth, but don't forget about this x minus 5. Now I have the same base. It's very similar to the logarithmic problems. You have the same log on both sides, so you can just set the arguments equal to each other. Here you have the same base, so you can just set the exponents equal to each other. So I have x plus 1 is equal to 4x minus 20. Notice I distributed there. Subtract x from both sides, add 20 to both sides, divide by 3, and you get x equals 7. All right, so now for exponential functions, you don't have to check your answers. As we saw when we graphed exponential functions, exponential growth looks like this, exponential decay looks like this. Either way, the domain's all real numbers. Any x value that you get as a solution works. Logarithmic functions look like this. So there is a restriction on your domain. Not all x values work. There's a vertical asymptote, so that's why I have to check our answers there. All right, this one, I look at the bases. Can I rewrite them both to have the same base? I can rewrite this as 3 to the first power, which it already is, and I can rewrite 27 as 3 cubed. So now I have 3 to the x minus 2 is equal to 3 cubed. There's nothing here, so I don't have to worry about writing it down. My bases are the same, so my exponents must be the same. Set your exponents equal to each other. Solve for x, you get x equals 5. Once again, the original equation was a exponential function, so you do not have to check your solution. All right, last situation, which is not on your homework tonight. The only types of problems on your homework tonight are everything we've done so far, is when you can't rewrite it as the same base. So if you can't rewrite it as the same base, what you're going to do is you are going to use logs to solve it. Why? Because this is an exponential function. I need to undo it. What is the inverse of exponential function? Logarithmic function. So just like how I showed you change a base formula, we're going to log both sides. Use your exponential property that says you can take your exponent and write it in front of your logarithm. Oops. And then finally get x by itself. Realize this is x times log 3. When we put it in front, it becomes a multiplier. Divide by log 3. Divide by log 3. Gone. X equals, and This here says calculator, but to be honest with you, it's actually no calculator, and it's only because we want you to leave your answer in terms of logs. So we're going to leave our answer as log 7 over log 3. Now you might be asking yourself, couldn't I have just written this as log base 3 of, and then rewritten it like that, like root right of 7 equals x, and then use your change of base formula to get this? Absolutely. Now let's try, the only problem is that this won't work, if there is an exponent on each side. If there's an x for an exponent on each side, that won't work that way. So that's what we'll see tomorrow. All right, this one, I want to first see if I can rewrite these as both as a base of 2, but I have this 3 in the way. So I'm going to start by dividing both sides by 3 to get it out of the way here. 2 to the 4x plus 3 equals 6. I'm going to look at a 2 and a 6 to see if I can rewrite them as the same base. 2 can be 2 to the first power. Can 6 be 2 to some power? It can't. People want to say, oh, it's 2 times 3. I'm looking for exponents here. So I can't rewrite them to have the same base, so I'm going to log both sides. Once again, I'm going to use that property that says I can take my exponent and have it as a multiplier in front of my equation. And now I have to get x by itself. Remember, this is multiplication here, so the first thing I'm going to do is I'm going to get rid of the log 2 by dividing both sides by log 2. Gone. Now I have 4x plus 3 is equal to log 6 divided by log 2. Please don't change this to log 3. It is not log 3. That's not how our properties work. So now I need to get x by itself. What are the steps to getting x by itself? If I said get x by itself, I'm not showing you what's over here. What do? Subtract 3, divide by 4. So I'm going to subtract 3, divide by 4. So my final answer is x is equal to log 6 divided by log 2 minus 3 all over 4. We'll see more problems like this tomorrow. Please remember that there's nothing like that on your homework because I feel like we need to practice it more. So go ahead.